And so when I saw the call for papers, there was a suggestion for a topic that was exactly this, and I thought, what a great way to come here to talk about doing FreeBSD stuff, which is fun, and do a little bit of security research at the same time. So made up the slides you see in the book there, and as we'll see later in the talk, I decided that really wasn't enough, that I really needed to do more. So about the first 2/3 of the talk are what's in the book, and then we'll talk about some new things that I've done since the CD was cut. So So we've got about an hour and 15 minutes or so. We have more than enough material to fill up here. And to begin with, I've got a picture of a scenario here that sends a couple of messages. One of those is that you really need layers of security to be effective, and that concentrating, a lot of people and a lot of technology in one layer doesn't mean you're necessarily going to be able to keep people out. And the other is that the guy in the bulldozer seems to be having a lot more fun than the others. So where do you begin? To really get a good overall picture of how to build a good security architecture, you really need to think in advance about establishing a good security policy. And that's the kind of thing that brings together all of the technologies. So what is a policy? It's a high-level set of goals.
Sir?
Yes?
Okay.
Okay. Sure. So that, yeah, wow. So a policy is a set of high-level goals and acceptable procedures that's, in this case, intended to secure the systems. And it's a life cycle, so you have formulation of policy, tools that act on the system, and tools that react. So what are the goals? What do you want to protect? What's important to you? FreeBSD is very common as a server operating system for web farms. It's also very common for home use and research. It depends on what kind of services you're providing and how long you want to protect your data as to what kind of tools you use. So setting those kinds of things in advance helps you determine the others. Determine things like what are the procedures for achieving confidentiality over a period of time, and what is the impact of implementing those? What does it do in terms of access, providing access to the network, applications, and users? So how do you begin to think about policy? Well, firewalls are something that are pretty well understood in terms of formulating policy. It's probably one of the first things you would try to acquire if you wanted to build a security architecture. How do you begin to talk about concepts for firewalls? Well, you talk about things like don't talk to strangers. Only let in things that you recognize. And in God we trust, all else we monitor. So for all kinds of exceptions, keep records of it, keep audit trails. So So how do we apply this to FreeBSD? How do we apply things like default deny rules, authenticate everything, log all exceptions? There are a whole set of tools for the system to do this, and the firewall is a good place to start in terms of blocking non-routable addresses, spoofed addresses, source-routed IP, allowing TCP only from specific subnets, specific hosts. And I think I've got a slide in here later about the default firewall configuration policies that are supplied with the system. One of those is called Simple. And in that, it blocks these sorts of things: non-routable addresses, spoofed, fragmented packets. That's a good place to start. From there, the kinds of things you want to consider are, given the kinds of services that you want to deliver, what kind of authentication do you want to provide? Do you want to provide anonymous services at all? Do you want to allow clear text passwords? Do you want to allow even clear text over SSH? How strong do you want your authentication to be? So there are strong authentication methods for remote shells, for web applications, and for all of these, having significant auditing helps you get some visibility over how effective they've been and how you can refine those as you go forward. What kinds of things do you want to log and enable to enable yourself to refine these rules as you go forward? Well, of course, you want to log all spoofed addresses, things on your subnet that shouldn't be happening, anomalies with respect to networking, so that if you're getting attacked a lot by a particular subnet or domain, you have the information there to assess it and block it, just like you would with spam. Denied accesses, give yourself some visibility to who's trying to get in, and tools like Snort provide you depth of monitoring for specific kinds of exploits and specific kinds of attempts. So for all of these, what are the elements of a security policy? As you enforce the policy, there's two kinds of things you do. You push the policy out to harden the system and control access, and then monitor it for policy violations with respect to access control or with respect to acceptable use. And how can you apply these to the network? Well, you've got several layers with which you can apply the policies. You've got your IP stack. There are syskettles that tune the stack to allow various flavors of the TCP protocols, tuning with respect to how long you'll leave connections open, how long you'll leave, you'll let, tuning for how many connections you'll let open at one time. Then you've got firewall rules, the most common, the IP firewall. As I said, there's a simple configuration that provides about 45 rules, mostly for blocking spoofed addresses. That is a good basis for refining it in terms of the specific services you want to provide. On top of that, you can use TCP wrappers that's integrated into inetd. So for a given service, you can get finer control of accepted connections based on users, time of day, in addition to source addresses. And finally, access controls, defining users and groups and the ACLs on the various parts of the system. So these are a couple of the syskettles that you can apply to the TCP stack in particular to log connection attempts. So if you have a connection to a non-existent service, turning these on will give you a record of all the attempts to probe, for instance, probe for services. And this can help, this tunes it to the extent that you're getting records of specifically that, attempts on things that you're not providing. As I said before, there's a couple of different default firewall configurations. The simple configuration is the most extensive of those, and these are the options that you would put in your boot up script to select that. So you want to turn it on, select a particular flavor, and if you like, enable logging. With respect to inetd, this is an example of the kinds of things you can do with the extensions to inetd that use TCP wrappers. So here we have policies with respect to IPsec that define what transports are accepted, and here what specific addresses are allowed. In addition, you have host.allow and deny. Host.deny file tells you what's not going to be permitted, and this is a basic default deny all rule here. So begin with the default deny all, and then the host.allow. Add in the things that you want to specifically allow. Everything else is locked out. If you want to verify that those rules are being parsed correctly and implemented well, there's a utility called TCBD check that will verify the rules. And so we've talked about hardening the network. What can you do to harden the host? Well, there's a set of, these are the known vulnerabilities for FreeBSD 4.5. There are a couple of that have come out for 4.6 just in the last week or so. How do you protect against them? Well, one of the most effective ways is to use package add. Well, convenient. Use package add, grab the most recent package from FreeBSD site and install it. So, and here is the address of those for the 4.x branch. Secure levels are another layer of security offered in the system. A secure level is changes the properties of the system based on one of four levels. Default level 0, the system operates as it has in the, over the last 10 years or so. When you raise it to higher secure levels, it'll start to turn off certain features like being able to mount file systems, being able to read from raw file devices. Now, you can raise that number, but it can't be lowered using any of the tools on the system, even by root, once it's raised. So the only way to lower it back down is to go through a full boot. So not even shutting down the system, a single user can do it. You've got to fully boot the system again to change it. So one of the drawbacks of that is it takes some effort to stabilize those before you can really before it's convenient to leave it raised. So at secure level 1, that's the first of the 3, you can't change immutable flags. Normally when you install a kernel on FreeBSD, it'll set the immutable flag for the kernel itself. That's one of the few things that the system already has that configured for you. So that, by default, when you raise it to level 1, the kernel itself is protected, or that file is protected. You can't mount new file systems. You can't write to kernel memory, which makes this hard to use for a desktop because the x386 server needs to write to that for access to video memory. And you can't load kernel modules. At secure level 2, mount is the only thing that can open raw disks. You can only make small changes in the system clock, and the firewall and dummy net, which is often used for load balancing, those kinds of things, those rules are all fixed. So the caveat is this is hard to stabilize because it's hard to experiment. Once you raise it, you can't, you've got to reboot to change it. And the other caveat that is it's actually raised relatively late in the boot process. So setting it to 3 protects you once init, starts all the processes, but before that point, it doesn't provide any protection. So here's a couple of commands that you would use to harden executables. The kernel, by default, is installed this way. In a similar fashion, you could apply to everything in user bin, user sbin. Those are things that you would normally expect not to change, and this is a way of enforcing that. I'm going to skip through some of these. SSH, they're using host.allow or not using host.allow, and stronger authentication methods is one way to refine the kind of access you allow, refine it in terms of narrowing the focus, and listening on a non-standard port. It's not necessarily going to protect you, but it'll filter out a certain amount. There's a bunch of good log monitoring tools. Chris Boyd has a good article on SANS about using these. And I will step forward. Okay, here's the last slide of the first section. And this is about future work. Robert Watson is now the leader of the FreeBSD team. He's responsible for Trusted BSD at NAI Labs. And he has implemented access controls in the system. So mandatory access controls are there in the kernel and the file system stack. I believe they have not been implemented in the file system itself. So UFS is the next piece that's needed, and with that they will probably have mandatory access controls. Keeping abreast of vulnerabilities, there's a mailing list that is both moderated, it's highly moderated. You get just the notifications for each new vulnerability that comes out, and there's an archive for those. Okay, there's access controls. So what's wrong with this picture? Those are the slides that for this presentation. And I gave these slides a couple of times and began to be a little bit uncomfortable about this picture, because even starting out with good high-level policy and drilling down into all the tools that you can use to refine access to the system, it's still possible for people, very bright people, to find holes. So at any given layer, somebody with diligence and intelligence can find a way around. So what can we do about that? Build tools for more layers. So I went out and built a tool. And between the time that I decided that and the CD was cut, I decided I needed to do something for remote exploits. And I think the Gobbles SSH exploit had come out recently. And so that was a real shocker. So what do? Well, intrusion prevention is one of the kinds of things that can add a layer of security that's not often used as it stands. So, should I build some intrusion prevention? I decided, yeah, let's do it. You guys are the only ones that know about this so far, because it's pretty new work, and there are a couple of other reasons. But it's on the conference CD. I got the code working in time to get it on the CD, and that was all the time I had. I couldn't get the slides done. So what does it do? Intrusion prevention does syscall filtering based on which call it is, file name arguments, user ID, IP address port, socket addresses. It adds another layer of auditing between userland and the kernel. It can block specific syscalls for specific applications. It can block access to specific files. It can even block specific addresses and ports. Now, this specific implementation looks a lot like TCP wrappers. It's well suited for remote services. It's not very well suited for local things. And like TCP wrappers, it's convenient to call this from etc inetd. And so what's the most common payload for exploits of remote services? Maybe we should have a vote here. Has anybody got any suggestions? My guess is shellcode. There's a whole lot of it. It's getting pretty sophisticated in that people are writing polymorphic stuff that'll run on Linux and various FreeBSD versions, and it discovers the version and then uses the syscalls for that particular version. So how can we stop these kinds of remote root exploits? If we block spawning of bin shell, that's going to cut out a large number of them. I don't know what fraction, but it seems like that's very common payload. Okay, so how much time do we have left? 30 minutes? Great. So we should have time to go completely through this demo. Let's see. Okay. So here we have FreeBSD 4.6, which came out, early this month. And I've got 3 windows here. One where I'm going to run the server. Okay, so this is running the OpenSSH daemon on a specific port here. And what I've done is I've wrapped that with a command called systrace, which reads a policy file for this service, and -a says use a default deny policy. So if the syscall isn't specifically listed in the file with some kind of rule, it's going to block the syscall and return an error code of some kind, like access not allowed, or -1 is going to mean something for various kinds of syscalls. And over here we've got the policy file open in an editor. Now I generated this policy file by running that systrace command once in an automatic mode where it monitors all the syscalls, and when the application exits, it spits those out as a policy. So what you see here is a list with respect to time of all the syscalls that were made. So it did syskettle, memory map, get UID, all of these, and you can see it loading all of the DLLs or shared objects. And then I've taken one rule and put it up at the top. This is where where it executes bin shell. And I've said at the end of the rule, permit this. So we're going to look at, we've got the server running over here, and we've got a client that's going to use the off by one exploit in the channel to try and get a remote shell, not as the user, but as root. So we've got here a bunch of options that tell it it's FreeBSD, address that it's going to try and jump to, and here we've got a remote shell. So who am I? I'm root. I'm in the root of the file system. Oh, well, that wasn't in the policy. Yeah, so it's a little bit limited, but we've got a remote shell. I'm going to try this once more after we change the policy. Okay, let's change this from permit to deny. Let's restart the service. Okay, there's the server side. And let's rerun the client. Now it depends on the application what happens, but the application is just going to see that a system call returned an error code. And a lot of times, if you block error codes that it would never suspect would fail, it'll do strange things. What that means is that you'll see them core dump a whole lot. Let's see now this, yeah, okay, so core dumped. You have buffer overflow, the exec failed, and it went on executing something, Lord knows what, and dump core. That's the kind of thing you can expect, and in addition, you can expect to see the denied calls logged in the syslog. So that's it. That's what we decided to do. It works against stock FreeBSD 4.5. That's what's on the conference CD. So if you see a file name systrace for FreeBSD 4.5, those are the sources. We looked at a filtering policy specifically for bin shell, and we could have added to that permit it only if it's not root. A caveat here is that if you were authenticating as root, and if the authentication is valid, this would still block it. This is based on systrace for OpenBSD. As I said, the tarball's on the CD, and we ported it to 4.6 a couple of hours ago, and that was what we saw in the demo, was this working on 4.6. And so we're looking for suggestions on where to go with this in the future. Red Hat 7.3 is an obvious target in terms of number of people that would benefit. Another thing to improve would be the ability to generate policies automatically to make it more usable over a wider range of applications and make it more transparent in terms of how the system uses it, how applications use it. And that's it. Am I close to the end? Oh my. Yeah. Okay. Yeah, let's take a look at automatically generating a policy. So this is the file that I generated earlier. The way that you do this let's see. We'll invoke systrace with a minus capital A. That's what tells it to generate a policy on the fly. Give it the name of the service. And execute the client. And it'll take a minute for it to authenticate. Actually, I should remove this. Okay, this should get through. Should be able to get a shell. Well, I don't want to waste your time, but that is the process. You give it a minus capital A. It'll generate a file, in this case, of about 100 rules. And you can take those and abstract them into, you can open them up in terms of, whereas opening up shared libraries, just say permit for, that whole class of files, or for that whole native open call, permit every open, and simply deny exec VE for bin shell. So it's relatively easy once you have that file to tune it. Are there any other questions? Does anybody have a question about how systrace works, what the code does? Richard.
Can I ask you kind of a newbie system administrator question?
Sure.
SSH is included in the install, and it seems to be a lot easier to keep track of it and update it and such as it's proportional. So what's your preferred method for keeping something like OpenSSH current? And if it's first loaded, it's in user estimated bin, then later on if you want to keep it updated, use a banner like report upgrade or something like that. It's easier to manage proportionally.
Yeah, it is easier to manage it from ports. And that's what that package installer does for you in general, is help you install ports. So
Would it make more sense to not have SSH installed so that you just install it cleanly from the beginning?
or simply in your etc rc.conf file, There's a variable SSHD file name. So you'd have all those options you would normally use, but just add another one that says which file it invokes. So it's that one-line change to select the port rather than the system. And that's what I would do. And then your configuration files are in different places. They'll be in user local etc rather than /etc SSH. I think used to be the default SSH was not open SSH, but in 4.6 it's definitely open SSH. So I can't recall when that changed. So all your keys and your configuration files you can copy over. I haven't, well, yeah. There are various kinds of forms. I don't know what other kinds of trusted, like Pitbull. I'm sure has some elements of this. NT provides some kinds of things that are related in that whenever you get you get handles on objects, whether they're files or sockets or anything, any kind of resource, you've got a number that's an index into something in the kernel, and you make the syscall, and it looks at that object for not only access to the object, but often, policies related to that. So it's mostly access controls, but there's also, system configuration relating to it. And that's related in that, kernel objects, devices, all those kinds of things have that kind of property. They don't have that in Unix. And the answer is probably somewhere in between. Mandatory access controls can't do everything, and this can't do everything on its own either. But maybe the right kind of interface is somewhere in between that.
Can you tell me that for setting up systrace, is that already put together as a package? Or how do you have to put it together? Do you have to go ahead and compile that?
Yeah, as it stands, the sources on the CD, there's a short README about how to, there are patches for the kernel, so you'd apply those, build a kernel, and then there's a tarball tree for the user application systrace that we invoked, and an X-window application that it will feed events to. Now we didn't execute it in that mode, but those things are there, and you can compile the userland things separately. So you patch the kernel, compile the userland stuff. Now there was one caveat about using this stuff. I did not get any chance to test it before I put it on the CD, and there's one nasty error condition. If you try to apply a default deny, and the policy file doesn't exist, the kernel will panic. So there's lots of quality control left to be done, and lots of testing left to be done. So if you start to use it, the next tarball I put on my website will have more of that explicit. I didn't have time to do enough QE on what's on the CD, and it's marked as such, as a work in progress. But the sources are there. Need to feed it back to the FreeBSD team to get it integrated. I've been talking to them, as well as the OpenBSD author.
You're demonstrating for remote exploit. If you have similar for local remote escalation, function in the same way?
It would function in the same way. The difference is that this is, the way this is structured this implementation is structured, it works like TCP wrappers in that you'd have to actually, say if you invoke something locally, invoke the wrapper explicitly in front of the command. So you'd have to run systrace and then whatever command was being protected. And that's not necessarily what you would want for how you would want it to work for protecting things locally. How are we doing on time? We getting close? 35? 45. Okay. We can go back and look at a couple of the tools, the other tools that are associated with the system that I skipped through earlier. So there are a couple of categories. You got network tools for hardening the network and tools for hardening the host. And we talked about IP firewall, INetD, which now has TCP wrappers integrated into it. And on the host side, installing packages to upgrade things, the secure level. So secure level is kind of a nice layer. I mean, it's beyond, it is stronger than intrusion prevention is because it changes the behavior of the kernel in very specific ways. And it's not the userland application interface that's changing. It's actually changing the behavior of the devices like raw disks, changing the way the mount syscall works. And those sets of behaviors were premeditated. They designed into each of these levels various degrees of changes in the behaviors that would prevent, things. Sure. You can. So there's a, yeah, I think you have to be root to change it. But yes. And it changes it when the system boots up. So it starts at 0, and when it, yeah, and it'll stay 0 while you're in single user mode. When you go to multi-user, it'll raise it. If you, let's see, I think the default is -1. If you let it, if you change it to 0, it'll raise it to 1 when it goes multi-user. If you set, a value in one of the boot scripts, that will raise it to a higher, can raise it to a higher level. So, the first caveat is, it's not very good for desktop here. But a lot of home gateways, it's very easy to build a cheap home gateway with a cast-off PC. And that's the sort of way that I'm using it. So it's kind of it's both on the front line, but can be done cheaply. I'm not using the secure level yet, but I'm about to myself because, like you probably have a couple of PCs, and dedicating one to as a firewall gateway is an easy thing to do. So how do you begin to stabilize the secure levels? Level 1, you can make all of your executables that haven't been changed in a long time immutable. Got to watch out for devices. And you want to make sure a lot of the kernel modules are loaded dynamically. So Linux, the SMB, if you're mounting file shares from Windows systems, that'll load dynamically when you invoke mount. So if you're doing those things, you want to make sure that those get loaded explicitly during the boot up rather than dynamically later on. Let's see, mounting disks. That's probably not as much of a problem as firewall changes. So you want to make sure if your firewall rules are already stable, that's not a problem, but probably a lot easier to stabilize those without using secure levels in advance than doing them both at the same time. Okay, caveats. You still want to harden your boot process in terms of protecting your loader. It's a 3-stage boot process on FreeBSD. So running open source or the free version of Tripwire might provide you some protection there that you won't have until it goes multi-user otherwise. These are the commands that you would use to set the immutable flag on executables. Here we have a set of common services, and for each, analyzing what you want to provide and what kind of privacy you have is a good way of beginning to set a policy. For DNS, writing a firewall rule that restricts zone transfers to your ISP's DNS servers, a good idea. For web, disabling, if you're not using CGI or other kinds of application services, disabling them is a good idea because the exploits come out at a certain rate. Samba has inherently a certain amount of access controls that you can apply in terms of restricting remote addresses, and firewall rules are another good way to apply restrictions there. The SynMail that's bundled with FreeBSD has some utilities for creating SynMail configuration files. They use the M4 macro preprocessor to build them, and if you look in the source tree for SynMail, you'll see documentation on how to enable anti-spam, as well as some instructions on how to get the, I forget whether maps or orbs is still going on, but how to keep those up to date. And there's quite a rich feature set that you can use if you use the preprocessor for your SynMail configuration file. That does provide some good access controls there. And then you have Telnet, FTP, and Finger, and well, it provides a lot of clear text information that is probably better to avoid if you can. Secure Shell at least hides your authentication data, but it's not necessarily a total solution. There have been, I forget how many exploits have come out in the last month or two, and even OpenBSD has been impacted by some of these. So I myself use RSA authentication between home when I'm away with 4 kilobit keys. It's kind of a pain to set up the keys, but once you get them established, you don't have to use passwords anymore. And it's less well used, so it's less of a target for exploits. I mean, if I was, in general, designing an exploit, I would go after market share, try to find, and that's what you see in a lot of these, that the mechanism that we were looking at required a user ID and password to begin the authentication and exploited a buffer overflow that occurs, in the middle of the authentication. So when they were establishing a channel. So hiding these things doesn't protect you, but it does put you at the bottom of the bell curve in terms of visibility. And that's another reason, running SSHD on a non-standard port just makes it that much less amenable. So what I didn't talk very much about is monitoring. As I said, there's a couple of articles on the SANS website. One of them, Systems Under Siege, talks about using regexps to match interesting log entries. And this is really the heart of intrusion detection, or at least what the market calls intrusion detection these days. So if you're reviewing IDS products from various vendors, the size of the rule sets are a key characteristic. And there are a lot of open source applications, Swatch, Logwatch, with which you can set patterns that do exactly that. So here we have a list. Syslog Next Generation has regexps. Swatch is written in Perl, so it's got all that capability built in. Log Surfer and Log Sentry. So you've got a number of alternatives between integrated with the system to lightweight utilities to extensible with Perl. And took out the slides on AID, which is intrusion detection built on top of Snort. Okay. Acid, that's acid. Well, there's also AID. Okay. Acid. Right. Okay. Right. So both of those provide, AID and ACID provide reporting on, in one case, file system type of intrusion prevention, and ACID provides the network intrusion prevention monitoring. And those tools, one of the problems with those kinds of tools is it can provide you more data than you can look at. And you can be faced with the problem of having so much data that you really can't look at any of it. And it then becomes worthless. Unless you just want to look at, patterns and, how the ends of the lines change. And there are people that can analyze large volumes of logs and, amazingly enough, do pretty interesting detection just on those kinds of patterns, seeing them. I mean, they obviously are able to recognize more than that, but that's not something that I feel comfortable doing. So for me, using tools like AID and ACID are essential to really be able to apply those at all. Does anyone have any questions? What would you consider the next most needed tool? see. Actually, I don't think there are enough auditing, like system configuration auditing tools. And probably before that would be some kind of binary update mechanism like Red Hat has, and Windows Update. And I don't think that really exists for FreeBSD as it stands, although there's been a few projects that were related to it. They have CV SUP, and SUP was at it was at CMU. I think it was originally targeted towards keeping binaries up to date on machines across the campus. It's not been used that way, and that would help a lot in terms of closing known vulnerabilities. So that and auditing tools were not just analyzing the configuration, but analyzing it, asking a few questions, and pushing out configuration based on those. So making it easy to get the machine in some sort of reasonable state that you can then work from. I think that would be very useful. There are a couple of hardening scripts for various systems. There's not much for FreeBSD. There's Chris Calabrese and a couple of others have hardening scripts for Solaris on SAN's website. I know there's some Linux ones. I can't think of any names at the moment, but I think we ought to be doing some of that for FreeBSD as well. Any other questions? OpenBSD from the outset did extensive code audits, and they're also fanatics about design. So from a coding standpoint, they did the things that were clearly the biggest benefit. And it's unfortunate that they've had some exploits of SSH recently. So it happens to the best of us, but they had very well focused goals, going into that project, and they have not only continued to do that, but they've captured mind share for a lot of very effective new efforts. So this systrace utility is being done there because the rest of the system provides a kind of integrated vision for security, where that sort of work all fits together in terms of having leading edge tools for each layer of the system. So they're doing pretty well. They're capturing a lot of good new work lately.
Are you running VMware on your?
Yes, yeah. So in my day job, we do lots of different platforms, and this, actually it makes it easy to give your coworkers copies of, the system that's completely functional and bundled with all, a bunch of interesting security tools. So, and it's great for QA. It made this project go a lot faster, being able to, do the development without having to worry about, the health of your desktop. Yeah, yeah. So actually, the majority of the work in this was not the part where you were actually filtering syscalls. It was getting the device driver interface to work, and getting userland application to parse the policy file, turn it into binary, and to push it via ioctls to the device. So that's where most of the code is and most of the work, and VMware is great for solving those kinds of problems.
Can you give the URL for when you hit the new 4.6 port?
Yeah.
It's not the newer one that's easy.
So I will put it somewhere on our website, www.murphey.org, sometime by next week or as soon as I can get network access, sometime in there. And it will be patches to the kernel and source for all the userland applications. And oh yes, that's right, I completely forgot. We've arranged with the Capture the Flag organizers to put 2 FreeBSD machines on the public network that people can probe and do what they like with. We'll have a stock FreeBSD 4.5 and a FreeBSD 4.6 with the intrusion prevention wrapping the services on it. So, don't know how long it'll last, but it'll be fun. So that should be up all day Friday and Saturday. Anyone have a question? We close? Okay. Let's see. All right, I'll show you another demo. Let's do something easier, and I'll generate a system call policy file. Let's see. Okay, we've got a list of policies here. This is the userland utility looks for all the policies files in a subdirectory of your home directory. And that directory is named .systrace. It replaces all the slashes in the path name with underscores. And that's how it names the policy file. So we've got policy files here for bin shell, those SSHD daemon, ID, uname. Let's generate one for, say, bin date. Okay, so we got the date here, 6:04 Central Daylight Time. Okay, I'm from Houston, so that's why it's Central Daylight Time zone. And then let's take a look at that file. So it opens up etc local time and reads the time zone information from there. So let's change that file name. Let's alter it. And then go back and we'll run it again. With minus little a that tells it to use a default deny policy. So it's going to apply all those rules, and there's one of the rules that we changed that tells it whether the syscall for access to that file is it going to succeed or not. And because we've changed the file name, that particular syscall is going to fail. So let's look at what happens. We got the time, but it used Greenwich Mean Time zone to report it. So for this application, when that syscall fails, it just figures that the file doesn't exist in this case and uses Greenwich Mean Time zone time. And that's what the auto generated policy looks like. We can do the same thing for FTP. Let's see. See if I have it in Etsy inetd. No, I don't. Okay. So here's what you would do to wrap the FTP daemon. Let's find out where systrace is. User bin systrace. So we'll put that into the inetd-conf file here. We'll say systrace minus capital A, and then invoke FTP. We need to use the full path, actually. You got to specify full path so that it can find both the policy file and the executable. This tells it to generate a policy. And we don't have a policy file in the policy directory here. We enabled it, but we didn't bounce inetd. So here we'll tell it to reread it. Now we should be able to root. Let's say rich. Okay, we should have generated a policy file by this. And, is it still running? This is the trouble with doing demos without testing them all out in advance. Poor quality control. Well, I don't know where it went. I wonder if this is related to running it as a daemon or running it from inetd.
Where the FTP daemon starts at, is the policy file going to be written to whatever directory you're running in instead of that?
Normally it would write it into this work. Maybe. Where would it be executing? Let's try running the daemon from the command line here. Yeah. Oh, I had a typo in inetd? Okay.
Now, can you write policies on machine to another machine?
Yeah. I mean, you could copy the policy file from one machine to another,
Yeah.
and if it's sufficiently generic. I mean, there's nothing machine specific about these in general, unless you put specific usernames. But like not equals root is pretty general. So the things we're looking at here, you certainly could. inetd. That looks okay. I think that's okay. That's Emacs giving us a cue. No, we've done, systrace is the command it actually invokes. Does that help? I think it must be something to do with the execution environment when inetd forks systrace. It must look different than the command line. So let's okay, we gotta use the full path. It's user lib exec ftpd. So, no. Well, rather than sort that out here, I think tell you what, I'll have some of that available for you at the DEF CON talk, which is, I think, 5 o'clock on Saturday in the breakout room. I'll have a bunch more demos, and a lot of this was actually done today. So as far as getting the exploits working and the specific demo we're looking at here, a lot of that was done very recently. Okay, I think we're close enough. Let's call it a day. Thank you all for coming. Certainly enjoyed your company.